for your body diagrams, for Q1, it will experience a force towards Q2 since they both have opposite signs, but this force will be greater than that of the force that Q1 experiences due to Q3, since Q1 and Q2 have a lesser difference of distance from each other, and it will experience a force away from Q3 because they both have the same sign. For Q2, it will experience a force towards Q1 because they both have opposite signs, and this force will be smaller than the force it experiences from Q3 because they have a greater distance between each other. And the force that it experiences because of Q3 will be towards Q3 since they both have opposite signs as well. For Q3, it will experience a force away from Q1 because they both have the same sign, but this force will be smaller than the force it experiences from Q2 since they have a greater distance between each other. It will go towards Q2 because they have opposite signs. Okay, so let's list what we know. Q1 is equal to 25 millicoulombs. Q2 is equal to negative 10 millicoulombs. R, the distance between the two, is equal to 8 meters since Q1 is at negative 8 and Q2 is 0. And we already know that K is equal to 9 times 10 to the 9 Newton meter squared over Coulomb squared. We're solving for force, so it is our unknown. So we use the equation force equals K Q1 Q2 over R squared. Plugging in our numbers, we get that force is equal to 9 times 10 to the 9 times 25 times 10 to the negative 3, since this is millicoulombs, times 10 times 10 to the negative 3, since that is also millicoulombs, over 8 squared. So, simplifying this, we get that the force on Q1 due to Q2 is equal to 35,156.25 newtons. Now, let's start this problem as we did before for the other ones. So Q1 is equal to 25 millicoulombs, Q3 is equal to 15 millicoulombs. R, the distance between the two, is equal to 12 meters since Q1 is at negative 8 and Q3 is at 4. And K, as we already know, is 9 times 10 to the 9 Newton meters squared over Coulomb squared. So force between the two charges is what we are looking for. So we use the equation force is equal to K times Q1 Q3 over R squared. So plugging in numbers, we get that force is equal to 9 times 10 to the 9 times 25 times 10 to the negative 3, since this is millicoulombs, times 15 times 10 to the negative 3, since that is also millicoulombs, over 12 squared. So simplifying this, we get that force Q1 Q3 is equal to 23,437.5 newtons. Given that Q2 is equal to negative 10 millicoulombs and Q3 is equal to 15 millicoulombs. Along with this, we are given that R, the distance between the two, is 4 meters, and K, as we already know, is 9 times 10 to the 9 Newton meter squared over Coulomb squared. And force is what we are solving for, so F is our unknown. So we use the equation force is equal to K Q2 Q3 over R squared. Plugging in our numbers, we get force is equal to 9 times 10 to the 9 times 10 times 10 to the negative 3, since this is millicoulombs, times 15 times 10 to the negative 3, since that is also millicoulombs, over 4 squared. Simplifying this, we get that force is equal to 84,375 newtons. Now, in order to find net electric force, first let's create a free body diagram. So first, Q1 experiences a force towards Q2, and this force will be greater than that it experiences away from Q3, since they have a bigger distance between the two. And Q3 and Q1 have the same charge, so it will be away from it. While Q1 and Q2 have the same charge, so it will go towards Q2. So now we know that force on Q1 due to Q2 is equal to 35,156.25 newtons. and we're given that the force on Q1 due to Q3 is equal to negative 23,437.5 newtons. So in order to find the net electric force, we use the equation force on Q1 due to Q2 plus force on Q1 due to Q3 is equal to net for electric force on Q1. So 35,156.25 minus 23,437.5 is equal to net electric force. So thus net electric force on Q1 is equal to 11,718.75 newtons. To the right, because that is the positive direction, and this net electric force is a positive charge.
So we start the problem by listing a free body diagram on Q2. So Q2 experiences a force towards Q3 because they both have opposite signs, and this force will be greater than that of which it experiences from Q1 because they have a smaller distance between them, and will also go towards Q1 because they both also have opposite signs. So from previous problems, we know that force Q2, Q3 is equal to 84,375 newtons, and force Q2, Q1 is equal to 23,437.5 newtons. So now we are basically solving for the net electric force on Q2. So that's going to be our unknown. So we use the equation net force on Q2 is equal to force on Q2 from Q3 plus force on Q2 from Q1. Plugging in our numbers, we get that the net force on Q2 is equal to 84,375 minus 23,437.5, since they're in opposite directions. So we get that the net force on Q2 is equal to 60,937.5 newtons. To the right, since FQ2 Q3 is greater than FQ2 Q1.
Now we will do the same for Q3. So Q3 experiences a force away from Q1, since they both have the same sign. However, this force will be smaller than the force it exhibits from Q2, because Q2 has a lesser distance away from Q3, and the force due to Q2 will be towards Q2 because they have opposite signs. So we know that force on Q3 due to Q1 is equal to 23,437.5 newtons, while the force on Q3 due to Q2 is equal to 84,375 negative newtons. Again, remember it is negative because it's going in the opposite direction. So the force on Q3, the net force, is equal to the force on Q3 due to Q1 plus the force on Q3 due to Q2. Plugging in the numbers, we get that net electric force is equal to 23,437.5 minus 84,375 newtons, since adding a negative is equal to subtracting it. So net electric force on Q3 is equal to negative 60,937.5 newtons. And this will go to the left, since the sign on this net electric force is negative.